Hey guys, how's it going? Today I'll be showing you how to use Backtesting.py to backtest your datasets. Backtesting.py is pretty much a Python library that allows you to easily backtest datasets that you have to see whether your strategy is actually profitable or not. Well, let's get right into it. So first, we have a few imports that we need to declare. First one would be pandas. And the others would be importing from the Backtesting.py library. You want to import strategy and backtest. And another one that we want to import specifically for this strategy, which is the SMA 50 and 200 crossover, we want to import a crossover function within the backtesting library. So basically, if you haven't used Backtesting.py before, it's a pretty simple backtesting library that you can use and learn. I'll probably make another video where I would explain it on a very deeper level. But for now, I just want to show you how you can use Backtesting.py to essentially backtest datasets with the strategy that you have. So essentially, the backtesting.py, the final backtest you want to run is a backtest class, which includes the data frame, the strategy that you have written. For now, let's call it SMA cross. And you also want to declare the starting cash balance that you have and also commissions. Let's just say for now, let's just do $1 million. And let's say we want a commission of 0.2% since we're going to be trading crypto data. So once you finish writing all the logic, you want to run the backtest to show you the statistics of the strategy that you've written. So that would be bt.run. And then the neat thing about backtesting.py is it allows you to plot out a graph for you to better visualize your equity curve. So that'll be that. So once we have the final statements, let's fill in the logic. So first, you want to have a data frame. The data frame is pretty much your data set that you have that you want to backtest your strategy on. For now, I have a pre-written function file, which allows me to just use pre-written code just to speed up the process. And this function I'll be using is a pre-written function that allows me to convert the dataset into the specific values that is required for backtesting.py. I have a dataset for Bitcoin on the hourly chart for 100 weeks. And now we just want to get the path and just declare it so we can import in the data as a data frame. Once we have our data frame, we want to start creating the functions and the class for the strategy. So how backtesting.py works is you need to create the function for your indicator, and then you pass in your indicator function so then you can run it against all the data in the data frame. So now we want to make a simple moving average function, and it requires the value, which is the actual data, and the length would be the length of the simple moving average. And in one of my previous videos, I showed you how to create a simple moving average within pandas. So I'll just be using that logic. Be values dot rolling, and you want to rolling on the length, and we find the mean. So now we have the SMA function declared, we want to create the strategy class that we want to be testing on. So that's called strategy SMA cross, which is part of strategy. And then we want to, within the class, we want to have two indicators, the 50 SMA and the 200 SMA. So we want to have lengths of 50 and a length of 200. And now we want to essentially initialize the indicators for our strategy. So we make an init self. We're first creating the fast SMA equals to self.I. I is essentially the indicator class that you'll be initializing into the strategy. And it takes in the function that we wrote above, the dataset within the data frame, which would be the close for this instance, and we also want the length. And for the slow SMA, it's essentially the same thing, but just different variables. And there we have it. This is how we initialize the two indicators for our strategy. And then we want to create a next function, which essentially runs our strategy on every single data point. So for now, and the next function actually is where you want to put in the buy and sell functions. So for now, since we are coding up a SMA crossover strategy, we want our strategy to be buying whenever the fast SMA crosses the slow SMA. For now, before we buy, we want to check if there is any existing positions open. If so, we can just close it. And then we put in a market order buy. And if we have a crossover of the slow moving average over the fast moving average, then we want to first close out all the positions and then open up a market sell order. And there you have it. This is pretty much how we can code up a simple SMA crossover strategy. And if we were to run the backtest, we could see whether our strategy is profitable against our given data set. So to see our stats for the strategy, we can just print out the stats, which is actually calling bt.run. Oh, actually, before we actually run the dataset within Backtest.py, if the dataset contains too many candles, we actually can't plot the graph. So for now, I'm just going to comment out this statement, and then we can plot out the graph with with a different dataset. So now we're going to run the script, and there you have it. Backtesting.py just sped out our stats for the strategy that we just written. And here you see that this is our return, 24% over 2 years or 700 days around. And it's actually worse than just buy and hold. For buy and hold, it's essentially just we buy position and then close it at the very end of the data set. So this strategy is actually not profitable because it's a lot lower than the buy and hold. But yeah, that's a good thing, backtesting is just for you to make sure that the strategy that you have is actually profitable. And in knowing that this strategy is not profitable, you can just not use the strategy and then move on to a different strategy, which it saves you time and money. So it's actually good that we have found a unprofitable strategy. So then here are the other metrics that you might be interested in, but you can always have a play around with Backtesting.py and your data sets. And I just want to show you the plot and what it can actually show you as a graph. but we got to first change our dataset. And there you have it. So here again, it spat out the stats for our strategy for the new dataset. And here we can actually see that for BNB 1 hour data for 20 weeks, this strategy is actually more profitable than the buy and hold. As you can see that the buy and hold is actually -6, whereas the return is 3%. So we actually have a positive return, which is a good thing. But the data set is only 5 months. So you might want to find data sets and backtest it more thoroughly. But what I want to show you is when you ran this same script with the visuals, it spat out a nice little graph to show you visually when the strategy is actually buying, selling, and also your equity curve. So this is actually quite a nice little visualization that you can see just for you to better understand your strategy. And yeah, this is pretty much how you can simply code up a backtest for a simple SMA crossover strategy using Python and Backtesting.py. Thanks for watching.